Hi everyone, welcome to the special chapters of higher mathematics. This is the third part of the lecture on probabilistic decision making, and I call this part advanced part. We consider basic procedures for decision making. We've already considered the payoff matrix and how to accounting for probabilities for the states of nature, how to make decisions considering expected monetary value, and how to turn the payoff matrix into a tree of decisions. Now I found this example provided by the courseware, open courseware by MIT, Massachusetts Institute of Technology course on the decision making or games theory. This example involves the manufacturing example from manufacturing business. The decision maker is about to make a decision either to continue producing old product or switch to producing a new product. We have some initial conditions. The payoffs eventually obtained by the company will depend on the market conditions. If the market turns to be strong for the new product, then the payoff will be better, will be higher for the company. If the market will turn mild for the new product, then the payoff will be slightly less. But if the market turns to be weak for the new product, the company, instead of making money, will be losing money. So let's look at the payoffs and the probabilities and what we have at hand. The payoffs, or money earned by the company, will depend. If the company keeps producing the old product, the payoff, regardless of the conditions of the market, because the market is used to this old product, and the probability of this market being good for the old product is 1.0. So it's 100% sure that this old product will be sold and the company will obtain this payoff of $150,000. But if the company starts or switches to producing the new product and the market turns to be strong for this new product, the payoff will be doubled compared to the old one. So that's an interesting option for the company, which purpose is to earn money, is to earn profit. But the probability that the market will turn to be strong for this new product is only 0.3. However, if the market turns to be mild, the switching to the new product will bring less revenue, less income of $100,000 compared to the old product. But the probability of this event that the market will turn mild for the new product is 0.5. Now let's look at this fourth option. If the company switches to producing the new product, but the market turns to be weak, then instead of making money, the company will lose $100,000. And the probability of the market to be weak for this new product is not so low. It's 0.2. So we need to, our decision maker actually needs to analyze all this information and come up with the best decision option. He has just two different options: either to keep up with the old product, or switch to the new product. Now let's put all this information into the decision tree. Decision tree will look like this. We start this initial point. We initiate this point, or set up this point at the branching point. The upper arrow will show the new product switching to the new product. The bottom arrow will show the second option, keep up with the old product. If the company keeps up with the old product, then regardless of the market, the probability that the market will be good for this old product is 1. So the revenue will be 150 Ks or thousands, 150 kilo dollars. But if the company switches to the new product, then the payoff will depend on the actual state of the market. Actual state of the market, which are listed here. If the market turns to be strong with probability of 0.3, then the revenue will be 300 Ks. Or the market turns mild for the new product with probability of 0.5, then the company will get the revenue, less revenue, or lower revenue of 100 Ks. But if the market turns to be weak, then the revenue, weak with probability of 0.2, the revenue will be negative. So the company will start losing money instead of making money. Now let's employ this expected monetary value to this information, to this decision tree, and we'll find the best option available for the decision maker. Actually, which option to choose. But first, let's consider this backward correspondence to the payoff matrix. Actually, I've already told you that the tree of decisions is actually equivalent to the payoff matrix. It can be easily observed that these 3 branches representing same payoff and these probabilities summing up to unit can be combined together. So we have the payoff matrix representing just 2 decision-making options, A sub 1, A sub 2. A sub 1 standing for the switching to the new product, A sub 2 representing the option of keeping up with the old product, and different states of nature. S sub 1, market turns to be strong for the new product. S sub 2, market turns to be mild for the new product, and S sub 3, market turns to be weak for the new product. The probabilities are presented here at the bottom of the matrix. Now, let's calculate the expected monetary value for different decision-making options. Again, we multiply the payoffs for every particular decision-making option by the probabilities of considering corresponding states of nature. So we need to multiply this 300 by 0.3 plus 100, the second payoff for the second state of nature, times 0.5 plus minus 100 times 0.2. This is our result. So expected monetary value for the new product is only 120 Ks. And expected monetary value for the decision to keep up with the old product is 150 Ks. So obviously the best option in this particular situation is keep up with the old product. Keep up with the old product. However, these decisions or this expected monetary value depend on these probabilities. Depend on these probabilities. Probabilities of different states of nature. So far, this is all we know about the market, about the nature. Now, the market represents our nature. So this is all we know about the market. But nobody tells you that this information cannot be improved. And actually, this information can be improved. How do we do this? We do the market survey. So the market survey is the very powerful tool of dealing with the market, of studying the market. So the decision maker considers this possibility of commissioning a survey to be able to better judge the future market. But the survey will bear some additional costs, some additional losses. In this particular case, we set it to $20,000, the cost of the survey. Now we have two different decisions to make. We're getting to this multi-stage decision model. We have initial decision of whether to buy survey or not to buy a survey, the first branching point. And we have the terminal decision of whether to market the new product or not, depending on the situation on the first initial decision here. Either we buy the survey or we don't buy the survey. Now we have two-stage decision, two stages of decisions. This is an example of that these market surveys, they are part of every major executive decisions. You can pause the video and read this slide. I'm not gonna pause on this. Now, let's consider the results or this survey. Actually, no survey provides you with the perfect information about the market. Every information is represented, or market information, these survey results are represented by the probabilities, some probabilities. For example, these probabilities may look like this. We denote them as P, the conditional probabilities, S slash L sub 2, P, S slash L sub 3. These are the conditional probabilities representing the situation when the market survey indicates the market as strong. This S stands for the strong, M stands for the mild market conditions, and W stands for the weak market conditions. The second letter here, L sub 2, L sub 3, and L sub 4, stand for the actual market condition. So if we consider these conditional probabilities, the physical sense of this, the meaning of these conditional probabilities will be as follows. The first conditional probability represents the probability of the event that the survey will indicate the market as strong, and in reality the market will turn strong for the new product. The probability of this event is evaluated as 0.8, but it's only 0.8, so we have some probability that the market can turn up to be in different condition, not as indicated by the market survey. This second conditional probability represents this situation when the survey indicates the market as strong, but actually the market will turn up to be mild for the new product. The probability of this event is evaluated at the level of 0.2. So not so bad. And this probability, this third conditional probability, will represents the situation when the survey indicates the market as strong, and the actual in reality the market will turn to be weak for the product. The probability for this particular situation is 0. So that's not that bad. But anyway, the survey provides not perfect information. It provides just additional knowledge about the market in terms of some conditional probabilities. Now, we have different set of conditional probabilities. The market survey may indicate the market as mild. And again, we have combinations of different events. We have conditional probabilities. The market survey will indicate the market as mild, but the market in reality will turn up to be strong for the new product. The probability of this event is 0.2. This second conditional probability represents the situation when the market is indicated as mild for the new product, and it indeed turns to be mild for the new product. The probability of this situation is evaluated at the level of 0.6. And this conditional probability shows the situation when the survey will indicate the market as mild, but in reality the market will turn up to be weak for the new product. The probability of this is 0.3. So we have some ambiguity. We have some uncertainty. But obviously these probabilities improve our knowledge about the market. And we have the third situation. The market survey may indicate the market as weak for the product, and the market will turn up to be strong. The probability of this event is 0. The market survey may indicate the market as weak, but it turned up to be mild for the product. The probability of this is 0.2. This conditional probability shows the situation when the market survey indicates the market as weak, but the market indeed turns up to be weak. The probability of this event is 0.7. Let's note that when we list these probabilities as rows, for example, the probability of market to be strong given different actual conditions, these probabilities do not, in the rows, these probabilities do not necessarily sum up to unit, because they actually represent the same probability of the same event, that the indication of the market survey will be strong, but we have different conditions. Given market indicated by the survey is strong, given different actual conditions. So these probabilities do not necessarily sum up to unit. But if we consider the exhaustive states or probabilities of different events, the probability of market indicated as strong, the probability of market to be indicated as mild given the same condition, and the market indicated as weak given the same condition, these probabilities as column will sum up to unit. So they represent the probability of the exclusive and mutual complementing events. These probabilities, again, of the market indicated as strong, mild, or weak given the actual condition being mild, they sum up to unit 2. 0.2 plus 0.6 plus 0.2, they sum up to unit. And these three probabilities sum up to unit 2. So this is our knowledge as might be represented by the market survey. Again, it's not perfect knowledge about the market in the future. It doesn't tell you to which condition market will be brought actually, or in which situation the decision maker or the company will find itself. But it presents the improvement of the knowledge about the market as provided by the survey. Now we can set up the new decision tree with two branching points. First branching point, initial decision. Initial decision. Second branching point, terminal decision. Terminal decision. So at the first branching point, decision maker has to make the first decision, either to purchase the survey or not purchase a survey. Then, at the second branching point, depending on the response by the survey, because we don't know in advance, we don't know the actual response by the survey, but we can set up the decision tree and account for every possible response by the survey, which might be strong or mild or weak. So the market is going to be strong for the new product as indicated by the survey. The market might be mild for the new product as indicated by the survey, or market might be weak as indicated by the survey. Then depending on this response by the survey, the probabilities of different states of nature will change. So we set up additional branching point, but we don't make a decision here at these points. We just set up the data we had so far, the payoffs, depending on different conditions of the market. We had the payoff of 150,000 given that the company keeps up with producing the old product, or depending on the actual market condition, strong, mild, or weak, the company may end up with higher payoff of 300,000 or less payoff of 100,000 or even negative payoff, which is equivalent to losing money, of losing 100,000 bucks. So we need to put some new data onto this. We have to refresh all the data, all this information, the payoff. We have to account for the market survey cost, because these payoffs do not yet take into account the survey cost. So we need to refresh these numbers. We need to find the probabilities of different states of nature here, these different states of nature, and again accounting depending on the response from the survey. Again, we need to find these probabilities, which will represent the probabilities of new states of nature or states of the market, depending on the survey response, given that the survey response will be mild, and so forth. So we need to put some data, and we need to find the probability of these responses, the probability that the market survey response will be strong, the probability of the market survey response is going to be mild, and the probability of the event that the survey response is going to be weak. So basically, if we don't purchase a survey, this part we just repeat it because it's the old, because this is the previous decision making tree. We just put it here. That's the same old decision tree. So now we have to refresh the data on this decision making tree, a new decision tree. We get some new inputs. So the earnings or payoffs must be reduced by the survey cost of 2000 Ks. So L1, the payoff in case of old product, will be reduced to 130. The payoff L sub 2 for the new product is going to be reduced to 280 Ks. This is the payoff for the strong market, if the market actually turns up to be strong. The payoff of 80 Ks can be obtained if the market condition will actually turn up to be mild, or if the market turns to be weak, the company will lose the previous 100,000 plus additional 20 Ks, 20,000 bucks. So we also need to update the probabilities of different states of nature depending on the survey findings. Let's do this. We handle, and we know this from the previous course of probability theory, we handle the conditional and unconditional probabilities by the Bayes formula. Bayes formula is shown here. It connects different conditional probabilities of different events. And actually, it allows us to switch the place for the event and condition. So for example, this conditional probability shows the conditional probability of actual state of market, actual market condition, L sub J, J standing for different states of market. 2 for the strong market condition, 3 for the mild market condition, and 4 for the weak market condition. So this is the actual market condition. Slash, this is the market condition as indicated by the survey. It might be strong, and this formula is shown for this market for this condition as indicated as strong. Strong market is indicated by the survey. So the Bayes theorem allows us to switch the places for the event and condition. We see that this conditional probability, it's usually called likelihood. Likelihood. Shows the probability, conditional probability of the survey indication market is going to be strong, given that the actual market condition will turn up to be L sub J. So it's either strong or mild or weak. This unconditional probability is called the a priori probability. A priori. This probability, this conditional probability will be called posterior. Posterior. This denominator shows the unconditional probability of the event S. In our case, this S stands for the event that the market survey will indicate the market as strong. So this is the sum of these products, conditional probabilities of market indication to be strong, given that the actual market condition runs from strong to weak, times the a priori probability of the market condition to be strong, mild, and weak. So this sum represents the unconditional probability of the market indication of a market to be strong as indicated by the survey. So this is the Bayes formula. We use this Bayes formula to find these posterior probabilities, because these posterior probabilities will represent the actual states of nature depending on the survey results. So for example, this probability, we substitute J equal to 2 and we get the probability of the event that the market will actually turn to be strong for the new product, L sub 2, given that the market indication by the survey is indeed strong. So these are our probabilities of the new states of nature. To find them, we use the Bayes formula and we'll substitute the conditional probabilities provided by the market survey into this formula, and we use the previous probabilities regarding the states of nature as a priori probabilities, and we substitute everything here and we get the results. Now let's do this. Let's substitute some data and look at how it works. Let's do these calculations, consider these calculations for the survey result is strong. Survey indicates the market as strong. The payoffs will be denoted by this L sub 2 for the strong market, L sub 3 for the weak market, and L sub 4 for the mild market, and L sub 4 for the weak market. The prior probabilities indicate our previous knowledge about the different states of nature. So we had this 0.3 probability that the market will be strong for the new product, the probability of 0.5 for the event that the market is going to be mild for the new product, and probability of 0.2 for the state of nature that the market is going to be weak for the new product. The sum of these probabilities sum up to unit. So the sum of them is equal to 1. Now we substitute conditional probabilities provided by the market survey. This conditional probability is the probability of the event that the market indication will be strong and the actual market condition will be strong. This probability was evaluated by the survey as 0.8. We find this product, the prior probability of our previous knowledge about the market condition to be strong for the new product, times this conditional probability of 0.8, we get 0.24. We substitute these other two conditional probabilities for the same indication of the market review. The market indicated as strong by the review, but given different conditions. The next condition is market to be mild. This conditional probability is equal to 0.2, and this conditional probability of the event that the market will be indicated as strong by the survey, given that the actual market will turn to be weak for the product, which is 0. This conditional probability is 0. Now we sum up these probabilities, we sum up these products as commanded by the Bayes formula. We find these products, conditional probabilities times prior probabilities, divided by this sum. So the sum of these products will be, in this particular case, 0.34. And this 0.34 is the unconditional probability P from S, unconditional probability of the event that the survey will indicate the market as strong. Now we use this unconditional probability to modify, to normalize these products and obtain the new probabilities regarding the states of the nature. We actually divide this conditional probability, or this product of 0.24. We divide it by 0.34, and we get this new conditional probability of the event that the market will turn to be strong, given that the market indication is going to be strong. This conditional probability is equal to 0.706. So this is the first conditional probability of 0.706. We get the product of these two, conditional and unconditional, likelihood times a priori probability, divided by the unconditional probability of the market survey indication strong. We get this. We repeat the same calculations for the other two different states of nature. L sub 3, the actual market is going to be mild, and L sub 4, the actual market is going to be weak for the new product. We get these numbers, 0.294 and 0. We notice that these three probabilities sum up to unit. These three probabilities sum up to unit. They actually represent the probabilities of mutually exclusive and exhaustive states, depending on the same condition. the probability, these states, these mutually exclusive and exhaustive states are as follows. The market either to be strong or mild or weak, depending that the market, the survey indication will be market is strong. We repeat the same calculations for the other survey results. The survey may indicate the market as mild, or the survey may indicate the market as weak. Again, we repeat these same calculations and we find the new probabilities of states of nature, namely the market is going to be strong, given that the market indication indicated by the survey is going to be mild. The probability of this event is 0.143. The probability of the market to be, the actual market to be mild, given that the market indication from the survey is going to be mild. The probability of this event is 0.714. And the probability of the event that the actual market is going to be weak, given that the market indicated by the survey is going to be mild. The probability of this event is 0.143. Again, these probabilities sum up to unit because they represent the probabilities of the mutually exclusive and exhaustive states, three different states of nature, given the same condition. The market indication from the survey is going to be mild. The numbers for the states of nature, given that the market indicated by the survey is going to be weak, are shown here. 0 for the actual market to be strong, given that it's indicated by the survey is weak. The probability that the market is going to be mild, given that the indication from the survey is going to be weak, and that market is going to be weak when given that the indication from the survey is going to be weak. Again, these probabilities sum up to unit. The unconditional probabilities of market to be mild is 0.42, and unconditional probability of the market indicated as by the review as weak is 0.24. Unconditional probability of market indicated by the survey as weak. And this is unconditional probability of the market indicated by the survey as mild. So we put all this data on the new decision tree, on the updated decision tree. We put the new reduced payoffs here at the end. Reduced payoffs. We put different new updated probabilities of the states regarding the states of nature. So this 0.706, 0.294, and 0 represent the new states of the nature, namely the market is going to be strong, the market is going to be mild, or the market is going to be weak for the new product, given that the survey indication is strong. When the market survey indicates the market as strong. These are the new states of nature. And unconditional probability of the market indication for the market as strong is 0.34. Unconditional probability of the market indicated as mild by the survey is 0.42. And this is the probability of the unconditional probability of the market survey indicating the market as weak, 0.24. So depending on the survey result, either strong or mild or weak, we get three different decision trees or branches of decision tree. Because if the market indication is strong, we have this set of probabilities for these states of the nature. But if the market indication is mild, as provided by the review, then we have different probabilities of regarding the states of nature. We have different probabilities of the states of nature. Namely, the actual market turns to be strong for the new product with a probability of only 0.143. It's lower than corresponding probability here. And the probability that the actual market will turn to be mild is 0.714, which is higher than here if the market indication from the survey is strong. The same happens in the third branch of this decision tree. When the survey indicates the market as weak, we have zero probability for the market turning to be strong for the new product. 0.417 probability of the market turning up to be mild for the new product, and probability of 0.583 for the market to be weak for the new product. So how do we make a decision using this new information? We solve it backwards in time. We determine the best solution option at every terminal node, conditional on the decision makers being there. Find the expected monetary value for each terminal node and the decision option that maximizes the EMV, expected monetary value. And we put some arrows indicating the best decision for each terminal node. Now, we analyze this. We find the expected monetary values for every branch of the tree. For example, this upper branch stands for the old product. The company keeps up with the old product given that the survey indication is strong. Now, we obtain this value by just multiplying this payoff by this probability. We get 130,000. Now we get this payoff at the second branch here as maximum from three different payoffs, from three different expected monetary values, EMVs. We multiply this payoff times this probability. We multiply this payoff times this probability, and we multiply this payoff times this probability, and pick up the maximum. Obviously, the maximum here is, when we compute all this, it's 221,300 for this particular node. Then we move to the next decision tree, or the next branch of this decision tree. Again, we multiply this payoff by this probability. We multiply these same payoffs by the new probabilities of different states of nature, and find the maximum. Obviously, we get the same 130,000 here at the upper branch, but for the lower branch we have different payoff of 80,000, which is the maximum of these three. It's actually 280,000 times this, 0.143. Here we do the same. At the next branch we do the same. We keep multiplying, and we find other EMVs for different decision nodes. Now we maximize as we proceed backwards in time, or from payoffs to the initial decision through terminal decision. We repeat the same steps here. For example, we take this particular EMVs at these branches, at these two branches, and find the maximum. The maximum of these two of 130,000 here and 221,300 here. The maximum obviously is this one. So we put it here. We put it here. This one is here. Now as we move to the next branch, again we find maximum of this two. Obviously this one comes here as the maximum payoff, or maximum EMV of these two. Here we do the same. We find maximum of these two. Maximum of these two is here. And maximum of these two comes here. Now as we proceed to we reach this branching point. Actually, at this branching point, we need to make a decision. So, we need to make a decision depending on the survey indication: strong, mild, or weak. Again, we multiply these payoffs, these EMVs, times these probabilities. Again, we multiply this probability times this payoff, and we get the result plus. We multiply this payoff here times this probability and plus here. We put it plus, add it up here. And we multiply this times this probability, and we add it here. So as we find these products, we get this new expected monetary value, EMV. At the first branching point. The second one, again, we multiply this 150,000 times 1. We have only one branch here, so it comes directly here. Now we can make some decisions. So, initial decision. As we proceed from this initial decision point, we maximize the EMV. Obviously, when we analyze this EMV and this EMV, we see that in case if the decision maker or company buys the market survey, the EMV is going to be higher. The EMV is going to be higher. Instead of 150,000, the company may obtain one expected monetary value of 161,008. So obviously, the decision maker, if he is a wise person, he makes this decision to buy a survey, and he advises the company to buy the survey. Next, the next decision, either to switch to new product or keep up with the old product, will depend on the result provided by the survey. If the survey indicates the market to be strong for the new product, then the maximum of these two payoffs shows us that the company would better switch to the new product because it will get a higher payoff of 221,300 bucks instead of 130,000. But if the market survey indication is mild, then the best decision option is to keep up with the old product, because in this case the company will receive the revenue of 130,000 instead of 80,000. And if the market indicated by the survey is going to be weak, then obviously the best decision option is to keep up with the old product. So instead of losing money, namely minus 36,600, the company will still be making money. If the company doesn't buy the survey, the situation doesn't change. We don't get additional information about the market, and actually the best option here is keep up with the old product. Keep up with the old product. So this is how it works. Now let's analyze. Let's conclude this. Best decision. Best initial decision. Best initial decision. Assume that the decision maker makes the best decision at each terminal node if it's reached. We found the AMV for the initial node. If the company buys the survey, the EMV is going to be 161,008 bucks. If the company doesn't buy the survey, the EMV is going to be 150,000 bucks. So the best initial decision is buy a survey. Next, best terminal decision. If the survey result is strong, then market the new product. If the survey result is mild, then market the old product. And obviously, if the survey result is weak, again, market the old product. Conclusions. So I'm going to conclude with this. So please pause the video, read the conclusions, and try to summarize everything received so far in this lecture. Thank you, and until next time.